Hey guys, welcome back to the channel. If you're new here, my name is Charles, and today we're going to be doing part 4 of our cloud detection lab in Azure. So far, we've been able to configure and deploy our Azure resources, that being our log analytics workspace, virtual machine, and Sentinel instance. We've also been able to implement some virtual and network machine security best practices, that being our just-in-time access, as well as network security groups. From there, we were able to utilize data connectors to bring in our Windows event data into Sentinel. And then we were able to look at Windows security event logs and query those logs using KQL or custom query language. Today, we're going to be taking a deeper look into analytic rules, kind of understanding what those are and how they work in preparation for our final video, where we'll be writing our own custom analytic rule to detect potentially malicious activity on our virtual machine. So if we navigate over to Sentinel, if you remember from the previous video, I kind of pointed out this events where, as you can see, we got 1.2 thousand events that have been detected on our virtual machine. However, if we look at the alerts and the incidents, both of them are 0. And the main functionality of the SIM is to be alerted of security incidents, potential security risk going on in our environment in real time. So this is where it's really important to understand the definition of a security event and a security incident. So a security event is simply any observable occurrence in our environment. So if we want to use the example from last video, we were able to go to our logs, and then we saw all the instances of successful logons using that specific event ID 4624. So a successful logon would be a security event, especially if all the security controls that are appropriate are in place. So that would be our username and password are correct, and ideally we want to have multi-factor authentication on that logon. That would just be a security event. So we don't want to be alerted every time somebody successfully logs on, right? We only want to be alerted for things that could be a potential sign of compromise or atypical activity in the environment. And that's where security incidents come in, right? So with a security incident, there is something not normal, something that doesn't meet our baseline of typical activity in the environment that we're going to be alerted about, and we'll do an investigation to determine if it is something that needs to be looked into, or if it's just a false positive, meaning that after we did the investigation, there was no signs of malicious activity. So that's kind of where the security incident comes in. So if we want to use the logon example, say we have an account and within 5 minutes there were 50 failed logons from that account. That would be a security incident, right? Because that is a very atypical activity to have such a large amount of failed logons in a small amount of time. So the main question before us now is, how do we monitor for those anomalies, those things in our environment that are not normal? And that's where we have analytic rules. So the best way to show you is to kind of walk through what an analytic rule is, as well as the components of one. So we're going to do that by coming down to this configuration tab and clicking analytics. So with analytic rules, we have two options. We can either create our own, which we're going to be doing in our final video in the series. Make sure you tune in for that. Or we can select one of these prepackaged ones that come with Microsoft. So what we're going to do is, for the purposes of this video, just so we can understand analytic rules, we're just going to look at one of these prepackaged ones. So I'm going to type in Windows so we can look at some things that have to do with security, Windows security events, which is very pertinent to this lab. So let's take a look at this rule more in depth so we can get a better understanding of what analytic rules are. So we've got the name of the rule, and this rule is going to monitor for excessive Windows logon failures. So the little description says user has over 50 Windows logons failures today, and at least 33% of the count of logon failures over the previous 7 days. So this is the specific scenario that we're going to be monitoring for. And if we come over here to tactics and techniques, this is something we're going to get into more in our next video. But if we click the drop down, we see all these different tactics and techniques. So this is credential access, and there's some sub techniques such as brute force, credentials, exploitation for credential access. So basically, with something called the MITRE ATT&CK framework, again, we'll learn this more in our next video. These are kind of the different tactics that a attacker would use to get into your environment or compromise your environment. So here is going to be the credential access one, as we're dealing with logons where there's usernames, passwords, that sort of thing. So here we also have the severity. So anytime this alert fires, we can choose how severe it is. There's a low, medium, high, and that's going to help an analyst prioritize if we have several alerts. Obviously, if it's a low priority, maybe it can be pushed to the back burner compared to something that's a high priority and that has more of an impact. We want to look at that first if we're in a security operations center. So that's a very useful feature. And then here is really the main functionality of the analytic rule. So if you look at this query here, it's based on the same thing that we use to query our logs, which is KQL. So this is a very long query, but we can pick out some of the main components just so you have an understanding of what's going on. So we're going to go back to our description. And our description talks about having 50 Windows logon failures today and at least 33% of the count of logon failures over the previous 7 days. So we can see a lot of things in this analytic rule match up with that description. So for instance, we let the start time and the end time be 8 days and 1 day respectively, looking for that 7-day time period. The threshold, it said it was looking for 33%, so we got that 0.33. And the count limit, if we go back here, talking about 50 Windows logon failures, so we listed that limit at 50. We query the security event table. Another important thing that sticks out to me here is the 4625, which is the failed logons. As far as event IDs go, and then account type would be user. So then from there, another thing that might stick out to me here is the substatus. So we're looking at failed logons, right? And there are a lot of reasons why you could have a failed logon. So we have these different substatuses that correspond to different types of failed logons. So we've got the bad username and password, unknown username and password. Maybe it was misspelled, or maybe there's no logon servers available to service the request or logon. So all these potential things could lead to a failed logon, which is part of the atypical activity that we're monitoring for. Obviously, there's a lot more things in this query that you can take a look at, but that's kind of like the main thing, just so you can understand um, that it is the KQL logic that we used last video to come up with these alert rules. So that's the query, right? So basically, this is kind of the main thing that's going to search for this anomalous activity and kind of specify that scenario that was specified in the description. So from here, we also have something called entity mapping. And we have an account, we have a host, and a process. And basically, entities are kind of like components of things or of artifacts that happened uh, in the incident. So of course, there was a user account that was involved, there was a host that was involved, and there was a process that was involved. So we pull all that information out automatically in the incident. So say this alert pops up in our SIEM and the analyst goes to investigate, they can get the account name, the host name, and the process name that was used and already have kind of a baseline of where to start their investigation. We can see authentication logs from the account and kind of look at what happened there, or see some system logs from the host and see if there's anything anomalous there, or the process. We can kind of look at this process in maybe some endpoint solution and see what this process is actually doing on our system. So these are really helpful things to give to an analyst to start their investigation. After that, we have query scheduling. So basically, this query, in order to detect the scenario, this query is going to run a certain amount of times. So right now, it's set to the query being run once a day. So every day, this query is going to run and and look for basically all these conditions to be met. And if it's met, the alert's going to fire. And we're going to have to look at how far back are we going to look at for data. So right now we have it set for 8 days. So it's going to run once a day. And when it runs, it's going to look for data as far back as 8 days. So look for anything that meets all this criteria that happened within the last days. It's going to count for this query scheduling. And lastly, we have the alert threshold. And basically, that's just going to be uh, how many instances of this alert need to happen before we actually have it display in our sim. So basically, we have said is greater than 0. So if this basically happens once, we're gonna have this alert come to our sim because we have it set to 0. If we have it maybe set to like 2, this would have to happen 2 times before we deem it worthy of an alert. So that's really the main parts of the analytic rule. There's some additional settings in this tab, but really most of what we needed was in the set rule logic. Automated response is kind of the next level. So for instance, if we did this investigation and we figured out there's an IP address involved from maybe a country that we don't do business in that's conducting this password attack, we could maybe after we do our investigation, we could block this IP on the firewall, right? But that would be a manual process that an analyst or engineer would have to go in and do. However, Sentinel and other SOARs, so we're working with the SIM capabilities, but a SOAR is able to automate that response to an incident. So instead of an analyst going in and manually blocking this IP on the firewall, we could have an automation via some type of script. So Python. In Azure Sentinel's case, it's going to be through something called Azure Logic Apps. That's kind of like the main automation software. We could have that automation go in and block that IP address for us. So that's a really cool feature Sentinel has if we're using the SOAR capabilities. But we're not going to be using that for this lab. We're just going to be kind of using the SIM capabilities to generate alerts. So if I was going to use this rule, I'd go ahead and click review and create, and it's going to validate it for us. And then click create, and then we can go ahead and monitor for this specific thing in our environment. However, we're going to create our own custom analytics rule in the next video that has to do with detecting persistence techniques. So definitely make sure you tune into our next video. But that's definitely it for this video. If you liked it, make sure to leave a like, comment, or subscribe, and I'll see you in the next one. Thank you.